Welcome to our last example. For this question, yes, we still want to identify the local maximum, local minimum, and you can kind of think about what the end behavior should look like before you type it all in, just to make sure you're getting the right information. This is a degree 4 polynomial. The degree is even. So our end behavior, and I can tell this without even graphing it, but our end behavior is it not f of x. X approaches positive infinity. F of x should also approach positive infinity. And then we also have as x approaches negative infinity, we should still be getting positive values for f of x. Just as something to kind of keep in the back of our mind while we do our graph to make sure we did everything right. This is a degree 4 polynomial, so we can have at most 4 zeros. Or I should say we could have 4 zeros. Whether or not they are real or complex is a different story. So let's go ahead and graph this equation to see what we get. Pull up the graphing calculator. We'll go ahead and type in the equation. Then you can go ahead and hit graph. Okay, so we can see where a few of our local maximum and local minima are. Like I'm looking right here. I can't quite tell what the x value is. I can tell it's in between 0 and -1, but the minimum looks like it's about -8, or the y value, I should say. And then we have another one right here, and it looks like it's roughly at about 1, -4. And again, we calculate this, hit the second key, hit calculate. I'll go with the minimum first. Get really close to that minimum point, and it'll give us a guess. So we have about -0.5, -7.8. We'll get one of our local maxima. And for this function, it's our only local maxima. So again, hit clear, then do second, calculate. It's the fourth option down for maximum. Keep scrolling over until you're really close to that maximum point, but not quite there. And hit enter. Then you have to move over to the right of the maximum, hit enter, and let it guess for you. So we have x equals 0.6 and -3.9. And then for our last local minimum, I can see that it dips down really, really low, but I can't see it with the window that we have. So I'm going to hit clear. And sometimes this option will work. Let's see if it does. But if you hit the zoom key, the third option down you have is zoom out. So I'm going to hit zoom out. Normally it takes you right up to the origin at 0, 0. But because we've been tracing around the graph, it left us at our local minimum or our local maximum, which is fine. We'll check and see if it works. And for us, it's still not quite big enough. So I'm going to scroll, I'm going to hit trace, and I'm going to scroll over on this graph. And I can see our y value. We're getting way down to like -39, -51, and notice how the cursor moved off the graph. So that tells us we have to have a y on our scale. We have to have a y minimum that is less than -50. So if it doesn't quite work out, where you just hit zoom out and you can't see everything still, you can just manually adjust the window. Click where it says window. For the x minimum and the x maximum, the side to side, we were doing okay with the negative 10 to 10 range, so I'm going to stick with that. Negative 10 to 10, scale of 1. For our y minimum, I'm going to go with negative 60. And again, you have to hit the negative symbol on your calculator. You can't type in the minus sign because it thinks you're subtracting. And then for the y maximum, we don't need to go up incredibly high. I still like to see a few positive y values, so I'm just going to hit 5. And if you want a bigger scale than just 1, you can adjust that also. So I'll try 5. And if that doesn't work, you always have this option to keep adjusting your window. Much better. Now we can actually see where our local maximum is, even though I can't tell the value right now. I can tell it's at about negative 55 for y, in between negative 50 and negative 55, and about in between 4 and 5, 3 and 4 for the x value. So again, second calc, we want to calculate the local minimum. I think even here is okay to hit enter for your left bound because you want to make sure you're on the left side of the minimum. And then for the right bound, you want to make sure you're on the right side for the minimum. And then hit enter. And we have 3.7 and then negative 53.4. Okay. The other thing we need to calculate is the x-intercepts. And here again, you can see the scale pretty well still. Because we chose a smaller scale for x, I can still see that the x-intercept is going to be at about negative, I'm going to guess about negative 1.20. And then it looks like it's almost 50, but we can still calculate that. So hit clear. And then this time you want to click second calculate, select 0. And when you calculate the zeros, again, it's a left bound, right bound. So when you're calculating the x-intercept, you want 1 point just above the x-intercept on the left, and 1 point just below the x-intercept on the right, and hit enter. So it looks like our x-intercept is about negative 1.30 for one of them. And then we'll calculate the second x-intercept. Clear, calculate, and then calculate the 0 again. It's the second option down. Scroll over till you get close to the other x-intercept. And notice how this one jumps pretty quickly. It doesn't look like it's close, but that's about as close as we're going to get below the line. Maybe a little closer. Nope, we went positive there. So hit enter. Scroll over. Now we're above the line, so hit enter again. Or above the x-axis. And then calculate. Gets. So we have 4.8. And then again, this is a rounding thing. It's estimating, so it doesn't recognize that, yes, this y value is 0. But if you see a really small decimal like that, yes, you can assume it's 0. So we have 4.80. All right. So the last part is graphing. And notice how we didn't have a bunch of room up above the x-axis, but we had a lot of room below it. So I'm going to count out from 0 to negative 5 in both directions on the x-axis. I'll plot the x-intercepts first. And then we can plot our local maximum and minimum. I, on this graph, chose a scale of 5, and I went all the way down to -60. So I'm counting -5, -10, 15, 20, all the way down to 60. So I'm going to put that same thing on our graph. All right, and then our local maximum, it was 0.6, -3.9, so we're going to go about halfway in between 0 and 1 for x, and then close to 5, -5, for the y value. Our scale is bigger, so it's harder to be more accurate, but as long as you're getting pretty close, you're doing okay. And then for the local minimum, we have -0.5, and then -7.8. So right about here. And then our other local minimum was the one that was way down, almost at 4, and then -53. And then the last step, we can connect our points. And does it match the end behavior that we predicted right away at the start of this equation? Yes. As x is approaching both -infinity or positive infinity, our graph is increasing and approaching positive infinity. Okay, so that's all for section 5.8. Good luck. Let us know if you have any questions.